This is lesson 6-8, scale drawings. Measure the length of each item in a room, such as a gymnasium. Record each length to the nearest 1/2 foot. Let 1 unit on the grid paper represent 2 feet, so 4 units equals 8 feet. Convert all your measurements to units. Rather than go measure something, we're going to use the example that they've given us. We're going to convert these 3 items over here to feet. So our scale is 1 unit equals 2 feet. So in our first example, we're going to do 1.5 times 2, which means the basketball goal is 3 feet. In our second example, we're going to do 7 times 2, which means our bleachers are 14 feet. We should label these all feet. And in our third example, the door is 2 units times 2 feet, which means our doors are 4 feet in length. A map is an example of a scale drawing. Scale drawings and scale models are used to represent objects that are too large or too small to be drawn or built at actual size. The scale gives the ratio that compares the measurement of the drawing or model to the measurement of the real object. The measurement on a drawing or model are proportional to the measurement of the actual object. In our map, they ask us, what's the actual distance between Hagerstown and Annapolis? We've measured this distance. They've found it to be 4 centimeters. Their proportion is 1 centimeter to 24 miles. That's your scale from your map right here. So we set up our 4 centimeters that we measured to d miles. That's our unknown that we're solving our proportion for. The actual distance from Hagerstown to Annapolis, we do cross products, so we have 1 times d represented here and 24 times 4 represented here. So when we multiply those numbers out, we get d equals 96, not 9.6. It's actually 96. It must be a typo. So this, in fact, is also 96. So the actual distance from Hagerstown to Annapolis, based on a scale of 1 centimeter to 24 miles, is 96 miles. On the map of Arkansas as shown, find the actual distance between Clarksville and Little Rock. Use a ruler to measure. Well, we measure from Clarksville to Little Rock, and we find that to be 4 centimeters. So we set up our proportion. 1 centimeter equals 20 miles, as you can see here on the map. So our 4 centimeters would equal d miles. Again, cross products, 1 times d is d. 20 times 4 is 80. So the actual distance is 80 miles. Using a blueprint scale. On the blueprint of the deck, each square has a side length of 1/2 inch. What is the actual width of the deck? Well, our scale is 1/2 inch to 4 feet. We want to convert 2 inches to w feet. So again, cross products. 1/2 w equals 8. We then multiply both sides of the equation by the reciprocal of 1/2, which happens to be 2. So the actual width of the deck is 16 feet. On the blueprint of the living room, each square has a side length of 1/4 inch. What's the actual dimensions of the room? Well, if we look at our length here, we count 1, 2, 3, 4, 5, 6, 7, 8. So what that means is that we have 2 inches. So our scale is 1/4 inch to 1.5 feet. We have 2 inches over x feet, if you want to use x for your variable. Our cross products are 1/4 x equals 1.5 times 2. 1/4 x equals 3/2 times 2/1, or 3. So 1/4 x equals 3. Multiply both sides of the equation by the reciprocal to get rid of the fraction. X equals 12. So the actual length of our room is 12 feet. We'll do the same with our width. Again, our scale is 1/4 inch to 1 1/2 feet. In this case, if we count across here, we have 7 of those 1/4 inch units. So we actually have 1 3/4 here instead of 2. That's inches to x feet. Again, cross products, 1/4 x equals 1 1/2 times 1 3/4. 1/4 x equals 3/2 times 7/4. 1/4 x equals 21/8. Again, multiply both sides of the equation by 4/1. This gives us x on this side. Simplify here and here. We get 21/2, which we would rewrite as 10 1/2. So the actual width of our room is 10 1/2 feet. This is feet. This is also feet. Length of 12 and a width of 10 1/2, based on those proportions. A graphic artist is creating an advertisement for a new cell phone. If she uses a scale of 5 inches equals 1 inch, what is the length of the cell phone on the advertisement? Write a proportion using the scale. Let A represent the length of the advertisement cell phone. So 5 inches to 1 inch equals A/4 inches. Again, cross products here, 5 times 4, 1 times A. So the actual length of the cell phone in the advertisement is 20 inches. Okay, check your progress. Their scooter. We use a scale of 1 inch to 3/4 of a foot. That's going to be x inches on our scale drawing to 3 1/2 feet. We do cross products. We get 3/4 x equals 3 1/2. 3/4 x, we're going to multiply that by the reciprocal of 3/4 to get rid of the fraction. We're going to change 3 1/2 to 7/2. We're going to multiply that by 4/3. We simplify here and here. X equals 14/3, which we would rewrite as 4 2/3 inches, which would be the length of our scale drawing of the scooter, which has an actual length of 3 1/2 feet. In Lesson 6-4, you used ratios to convert units. You can use a similar method to simplify a scale. A scale written as a ratio without units in simplest form is called a scale factor. In this example, it's 1/4 inch to 2 feet. What we do here is we simply change this 2 feet to 24 inches. We divide out our common units. We multiply the numerator and denominator by 4 here because we don't want a fraction in our scale factor, and our result then is 1/96. In our second example, it's 1 inch to 6 feet. 1 inch equals 72 inches. In this case, we simply divide out the common units. We can leave our scale factor as 1/72 because we don't have a fraction in the numerator or the denominator. In example D, our ratio is 1 inch to 2 feet, which means 1 inch to 24 inches because that's how many inches there are in 2 feet. We divide out the common units, and our scale factor is 1 to 24. Find the actual distance between each pair of cities in New Mexico. Use a ruler to measure. Well, we've done that over here. We're going to simply move those down here and do these calculations. We're going to use this ratio each time. 1 centimeter equals 25 kilometers. As you can see, that's the scale on our map here. If the distance from Carlsbad to Artesia is 2 centimeters, we do 2 centimeters here. We'll just use x for our variable down here. That's kilometers, of course. So 1 times x is x. 2 times 25 is 50. So from Carlsbad to Artesia, it's 50 kilometers. In our second example, Hobbs to Eunice, it's again 1 centimeter to 25 kilometers. In this case, it's 1.2 centimeters to x kilometers. Cross products, we get x here. 25 times 1.2 gives us 30. So from Hobbs to Eunice, it's 30 kilometers. Example number 3, Artesia to Eunice. Again, 1 centimeter to 25 kilometers. We have 5.2 centimeters here to x kilometers. Cross products, x equals 5.2 times 25, which actually gives us 130 kilometers. And then our last example is Lovington to Carlsbad. 1 centimeter to 25 kilometers. 4.1 centimeters from Lovington to Carlsbad over x kilometers. Cross products. X equals 4.1 times 25, which turns out to be 102.5 kilometers. Example number 5. What is the actual length of the pool? Well, our scale is 1/4 inch to 2 feet. When we measure this, when we measure the length, we get 1, 2, 3, 4, 5, 6, 7. So that is 1 3/4 inches to x feet, which gives us 1/4 x equals 7/4 times 2 over 1. So 1/4 x equals 7 over 2. Multiply both sides of our equation by 4. Simplify here and here gives us 2. So x equals 14 feet. That would be the length of our pool. The width, 1/4 inch to 2 feet. We have 1, 2, 3, 4, 5, 6 there, so that's 1 1/2 inches instead of 1 3/4 over x feet. Cross products, 1/4 x, 3 over 2 times 2 over 1. Simplify, gives us 3. So 4 over 1, which is the reciprocal of 1/4 to get rid of the fraction. So 4 over 1 times 3 over 1, x equals 12 feet. So the width of our pool is 12 feet. Our last 2 examples here. It says an engineer makes a model of the bridge using a scale of 1 inch to 3 yards. So we have 1 inch to 3 yards. Our length on our drawing is 50 yards. We don't know the inches this time, but we know the yards. So we do cross products. We get 50 equals 3x. which means we're going to divide both sides of our equation by, not by x, but by 3. Which gives us a length of 16 2/3 inches. That's our scale. Our other example, 1 inch to 3 yards. In this case, it's x over 4, because our width here is 4. So cross products is 3x equals 4. Divide both sides of the equation by 3. X equals 1 1/3 inches on our scale for the length, for the width, I should say. Find the scale factor of each drawing. 1 inch to 4 feet. In number 9, 1 inch to 4 feet means 1 inch, 12 inches per foot, 48 inches. So our scale factor is 1 to 48. In our grasshopper, they're confusing us a little bit here. We have 1 centimeter to 15 millimeters, which means 1 centimeter to 1.5 centimeters, because that's what a 15 millimeters is equal to, which gives us 1 over 1.5. Now remember, we can't leave a fraction or a decimal in our numerator or denominator, so we're going to multiply both of these by 2, which gives us a scale factor of 2 to 3. And our last one, in the aerial view, the city block at the right, the length of Main Street is 2 inches. So we have 2 inches to 2 miles, which we're going to simplify to a unit rate of 1 inch to 1 mile. Now what they want us to do is to change miles to inches. So we have 1 inch here is 5,280 feet. That's feet per mile, in which we then have to change to inches per mile. So we're going to take our 5,280 times 12, which gives us 63,360 inches. So believe it or not, our scale factor is 1 to 63,360. Our 2 vocabulary terms, or 3, scale drawing, scale model, and scale, these should be in your child's notable. And if not, you can look them up on the online glossary. At this point, you should quit the video. Go to my Moodle page, take lesson quiz 6-8. Your username is your 6-digit student number. Your password is the first 6 letters of your last name. And your